This is Dr. Carroll, and this video is about writing classes. So let's start out by talking about a class is a data type. A class is also an abstract data type in that it represents some object that we've abstracted away. So generally when I talk about abstract data types, I talk about what are we abstracting away. So for example, have you ever driven a car? So what does it look like? You've got a steering wheel, you've got some pedals, and that's how it works. Have you ever turned the wheel, the steering wheel? So what happens underneath the hood? Is it using analog circuits, digital circuits, quantum computer? What is it using? Several years ago, I drove my grandfather's older truck. And when I turned the wheel, I must have been turning a gear that actually turned the wheels. You could feel it. I felt like I was getting a workout. But then if you get into a modern truck and turn the steering wheel, it turns easily because of power steering. And so why do I bring this up? Because what we've done is we've abstracted away the implementation details of what happens underneath the hood of a truck, to use some computer science terms in something you're probably more familiar with. And so the interface is the steering wheel and the pedals and other things. And so we've hidden the implementation details and allowed it to be able to change it without changing the interface. Let me use a different example. Ever used an ATM, an automatic teller machine? So how does it work? So put in your card, put in your PIN, out comes money, right? So what's going on inside the box? Are they using trained monkeys to control it? Are you sure? So are they using analog, digital circuits, quantum circuits? Who knows? And they could change it out without us needing to know. And so we don't need to know the implementation details behind the ATM, and we just need to, we're just familiar with the interface of what we can interact with in terms of the ATM. And so this is computer science. This, what we're talking about is information hiding, and it's a key ADT technique. And what it does is we keep implementation details out of the interface, or you could say differently, out of the public interface, but that's redundant. And this is also known as encapsulation. So what's in the interface? Everything that's public. Let's talk more about classes. The first method to execute a class is the constructor. So let's talk about constructors. A constructor is a special method that is called when code instantiates an object. Remember when we instantiate an object by calling new. Constructors exist to initialize the object. That's their role, that's what they do. This is mainly setting instance variables. There are some rules about constructors. For example, it must have the name of the class. This allows the compiler to know which method is the constructor. So let's look at an example. So if we had just a simple bank account here, then we're going to give it an instance variable, and we're going to make it private. That's typically what we do. Let's add a comment here. And now let's create a constructor. We know it's a constructor for a couple of reasons. One, it has the exact same name as the class. See that simple bank account is the method name here, and it's the same name as the class. Exactly, no changes. Okay, and we could have a constructor that doesn't take any parameters, or one that does have parameters. And so here we have, we're passing it a double, and then inside of this, we then take that parameter and set the instance variable. We initialize it here because the constructor is being called before any other code. by definition here. So we are initializing balance so that we can use it. So this is a simple example. Let's look at some code to call it. So if we had a transactions class and we put main in here, then we can declare a reference to an object named, and our variable name here is checking. So we're declaring a reference. Simple bank account is the class type, and so checking is a reference to an object of class of simple bank account. Initially, it is set to null, meaning it doesn't reference any valid object. And so Java does that for us for free, just to make it clear it's not set to any object. Otherwise, that would be bad if it was just random. So we've declared it, but we haven't instantiated an object yet. So we do that by the line with new, calling the constructor here. And how's that for a good initial bank account amount? Okay, so now we're using the keyword new, calling the constructor, passing it an argument, and this is creating a new object. It is instantiating a new object and assigning it to our object reference checking here. So the syntax for a constructor is public, and then the class name, and then set of parentheses, and then the body of our constructor. And we could optionally give it parameters. Here we have parameters and above. So notice it's just an access modifier in the method name, and it's always the method name always matches the class's name, and there's 0 or more parameters. So what's missing? Well, there's no return type here. And so if you look back at the code that's instantiating, so we're calling a constructor here, but where would it return it? That doesn't make sense. Its job is to initialize the object, and it does it. It doesn't need to return anything. So here we have an example of calling one if it didn't take any arguments at all. And so if we return something, then it would be passing it to new or something like that. So there's always no return type. There's nothing to return. Because constructors are essential to initializing object, if you don't put any constructors in the code, if you don't write them in the code, the compiler will generate one for you. And this one is called the default constructor. That's how important they are. And so the syntax of a default constructor is just public, the class name, no parameters, and no body. Okay, it's very simple. Oh, I have an open curly brace and no closing curly brace. Sorry about that for the default constructor syntax. So an example for an explicit default constructor for this simple bank account would be public simple bank account, open close parentheses, and then an empty body, and that's it. Okay, so generally if you write a constructor, it's good practice to write an explicit default constructor as well. Let's talk more about new. New is a keyword, and and it's always used to create or instantiate an object. New does 3 things for us. First, it calls a constructor. Second, it allocates memory for the object on the heap, which is different from where where we're storing it. It's creating it on the heap typically. And then third, it returns a reference. You can think memory location for the newly created object. And so that's what new does. We've already seen one example of this. Now, strings are a regular object, but they're so common in Java that it allows for several shortcuts, like not using new. So let's see an example of strings because we're familiar with them, but using the new construct to appropriately call them, formally call them, without taking this shortcut. So here's an example. I've declared 3 string references, string 1, string 2, string 3. And so let's call new 3 different ways. So we can call new with no arguments, and that's going to create an empty string. So right now, if we execute the code, string would be referencing a string object, which is storing an empty string. String 2 and string 3 are null. But if we added in more code, so here, if we can pass the constructor of string, we can pass it a string literal, and it will initialize it with that value. And just for completeness here, we can pass string 2, a method call on string 2 to string 3. And so that's going to return a string from here. Now, it will not change string 2 here. It will only change, it'll return a new one which never gets named. It's called anonymous because it's never named. We pass that to the string constructor, and then it will create a new string here. We didn't need to call new here, but we did. We could have just assigned it there. I was on a kick for creating or calling the constructor, and so I wanted some string reference, and so I created one by calling new or to uppercase. And so we can print those out. And so the first one would just display nothing, and then the next one would display hello world because it didn't change it to uppercase. It would display it with lowercase h, lowercase e, and then the third one would be all uppercase letters, hello world. And we could have combined these 3 lines with these 3 lines. We could have done that, but I was just pulling them out on their own line. Just want to make sure you knew that. Okay, so let's talk about naming conventions now that we're talking about writing classes. So classes and members, which are both data members and methods, follow the same naming rules as other methods, for example, variables. Okay, and so there's some best practices of how you should name classes and method. So 1, classes should start with the first letter should be capitalized. Okay, that also means your .java file will be capitalized as well because it needs to be the same name. Whereas methods, the first word should be a verb, and it should be lowercase to differentiate between the classes. So classes, first letter uppercase, but methods generally start with a verb as the first word. So constructors are an exception to this rule. They're a special method, and because they have to have the name of the class exactly, then they are going to start with an uppercase letter and not necessarily start with a verb either. Another exception to this rule is the main method. So let's talk about main. So execution starts in the main method. You can only have one main method per class, and it needs to be static so that it can be called independent of an instantiation of that class. Said differently, it needs to be called before we need to be able to call main before we instantiate the class. So static means just one copy of it for all of the class, and we cannot use instance variables. Watch my video on static variables and methods to learn more about that. Let's wrap up by talking about designing classes. And so we can have classes which hold instance data, and the instance data could be another class, a reference to another class. For example, you can imagine a bank account class that stores a name as a string. Well, a string is an object, and so we're having a reference to store another one. So let's imagine that we're designing a Java program to track how a user spends their money. So what kind of objects would we need? And so for a personal spending tracker example, we would have an instance variable for name, which would be a string, Then we probably also need some way to keep track of an expense. An expense has a lot of different details to it. So we'd probably create another class called expense. And so our personal spending tracker class would have instance variable of a name, which is a string. It also have something like an array or some other data structure to store several expenses as well, which is another class. So I just want to make sure that that was clear, that a class can hold references to other classes. That concludes it for this video.